To welcome Mr. Sakhr Yunus, please. Please join me here. Also, Mr. Khalil Saghir. Join me. Esteemed guests, friends, and colleagues, good evening and welcome to another event of AlNadwa Freethinking Society. My name is Abbas Youssef, one of the founders of AlNadwa Freethinking Society, where I proudly serve as its secretary. As we are gathering to discuss one of the most fascinating, however intriguing technologies and its impact on the future of humanity, we must remember those who did not have a chance on a future, and those whose future is still threatened. Please join me in recognizing the genocide that's still being committed these days in Gaza, Palestine, where over 37,000 killed and over 70,000 injured and over 1.5 million displaced, aided by our government and our Western governments. Please join me in a moment of silence, followed by a deep breath. Thank you. Esteemed guests, welcome to Dearborn, the diverse city where its people and leadership are standing on the right side of history, anti-deception, standing up for humanity and true believer in the core values of this nation, liberty and freedom for all. We at AlNadwa Freethinking Society stand for these values as well, and against discrimination, hate of any type, and apartheid. AlNadwa Freethinking Society is a Michigan-based, secular, non-profit organization. We are committed to promoting Arab American culture. We aim to set up events, talks, lectures, and interactive discussions where experts in various fields of science, humanities, and the arts are invited to inform, educate, entertain, and inspire. Our vision is to build a community that is not afraid to ask the hardest question. Artificial intelligence, or AI, is one of those subjects. AI is gaining popularity as a trending and emerging technology. AI is accelerating into a mega trend, transforming industries, companies, and the way we live and work. And it's being explored to be implemented in many areas of business. Many technology companies are developing tools to expand their use to perform different applications. With all its popularity, it is still a mysterious science to the public. Many believe it's the field of elites, scientists, and technologists that are designing machines to mimic the decision-making process of a human brain. Some believe AI is being implemented and advertised heavily as it is to solve humanity's problem and make life easier. On the other hand, many are skeptical about its impact on society. For instance, on the working class, as they feel they are being replaced by smart machines. In addition, there are concerns about the use of AI by students in ways curbing their ability to think critically, and therefore impacting their learning and their lives. Furthermore, some want to restrict its usage because they feel that if it overtakes a human, it will be dangerous for humanity, as shown in various sci-fi movies. Tonight, we are honored to have with us two Arab American professionals to address these concerns about AI. Our presenters will share their perspectives on what AI is, its history, how it works, benefits, value, its challenges, risks, and its present and future applications in the different industries, and particular examples of its use in education. Our presenters are Professor Sakhir Yunus and Khalil Al-Saghir. Mr. Sakhir Yunus is a professional engineer with more than 27 years of experience in information technology, with a focus on cloud solutions, artificial intelligence, the Internet of Things, and cybersecurity, among other areas. He is also an adjunct professor at the University of Detroit Mercy, teaching graduate schools in these subjects. He is a published author and public speaker about technology and technological strategies. He currently works at Ford Motor Company as a senior cloud architect. And Mr. Khalil Al-Saghir is a consultant at Wayne Risa with 23 years of experience in teaching at various levels, K through 12 and higher ed. His expertise includes training and coaching teachers and providing consultation to school districts on the development of and improvement of language assistance programs. He is a frequent presenter at state and national conferences, and he has been serving on multiple statewide educational committees as well as on the executive boards of prominent organizations in the field. Our program tonight will have 3 parts: a presentation by Mr. Yunus on all aspects of AI, and a presentation by Mr. Al-Saghir on one of the applications of AI, ChatGPT, and its use in education, and of course, a Q&A session. Please hold your questions until the Q&A session of the program. Without further ado, please help me welcome our presenters, Mr. Yunus and Mr. Al-Saghir. Mr. Yunus.
Thank you, Dr. Abbas. Thank you all, and we appreciate you guys coming here, taking the time out of your schedule, especially on a Friday evening, to join us in this session here. I hope that it will be beneficial for all of you, as I will try to present some interesting topics in different areas in AI. And soon as I get this to, here we go. So this is what I'm going to be discussing today. We'll go through some historical perspective. Then I'm going to take a closer look at AI and how it works. I will try to be at a high level because this is where the technical part is actually. I hope it's not going to be too technical. I will try to simplify it. If I use you guys, give me a signal and I will try to shorten it as much as possible. Then I'm going to discuss benefits, value, challenges, risks, and so on about AI. Then what does the future hold for us? And I think that last bullet is going to be very interesting to most of you. I hope you guys stay with me until then. So with this, I'm going to show this definition according to the Wikipedia. As you can see here, AI is intelligence of machines or software as opposed to the intelligence of humans or other animals. Basically, it's just like a regular benign. There? Okay. So it's just a benign definition. Actually, I did ask ChatGPT to give me the definition of AI, and this is what it gave me. I'm going to let you listen to it right now.
AI, or artificial intelligence, refers to the development of computer systems that can perform tasks that typically require human intelligence. These tasks include learning, reasoning, problem solving, perception, speech recognition, and language translation, among others. AI systems can be categorized into narrow AI, which is designed for a specific task, and general AI, which would have the ability to perform any intellectual task that a human being can.
Okay, so this is just like a brief, I took a snippet from what ChatGPT answered and showed it to you here. Just to show you that AI technology can even identify itself, which is kind of it's like a self-consciousness in a way. Self-consciousness is just knowing where you are and who you are, and your surroundings, the context that you're acting in, and so on and so forth. As if there's a hint here of AI having that capability. But anyways, I'm going to now start talking about this slide here. This is a poster that used to be an iconic poster back in the 90s and 80s. Actually, it was created back in 1983 by 3 people at a company called VM Software, not to confuse that with VMware, which is the virtualization company that was created 15 years later. Anyways, this poster was on the wall of the conference room in my first interview ever in the US, in Ann Arbor. And I asked the interviewer at the time, Dr. Paul Rogers of Gimnotech, the late Dr. Paul Rogers, and he explained to me, this is the wave of the future. This is about digitization. Everything will be digitized. And this is about the digitization of the economy. On the left, you see the regular wave. And you even see the little fractal nature of that wave buried on the edges of it. And then you can see transitions with those little squares to a digital form of that wave on the right-hand side. And ironically enough, those little squares actually were made with paper, painted paper. So this poster was made by hand. It was not really made on the computer. But at least it kind of showed the trend that was going on at that time over there. So why am I showing this? Why am I talking about a wave? Mainly because technology comes to humanity in the form of different waves. And according to different historians and technologists, the number of waves that humanity has seen, Homo sapiens, may differ from 3, like Alvin Toffler identified 3 waves, agricultural revolution, industrial revolution, and the digital revolution, all the way to other historians and technologists that identify up to 24 waves. The trend is that in the initial phase of human development, those waves were far in between. So it took more than 9,000 years between the agricultural revolution and the revolution where people started to use bronze and iron tools, basically, which made a huge difference in their destiny and the way they lived, in the way they fought. Actually transitioned society from city-states to empires. That was an inflection point at that point. So as you can see, technology can play a big role that comes in those different wave formats. And those waves continue to happen. And I'm going to describe one example of those waves. We all know that the Industrial Revolution started in the late 18th century. People differ whether it started in 1793 or 1788. Anyway, it started in the late 18th century. And that's when the steam engine came into being. Steam engine allowed for automation of a lot of things, like the looms, allowed for driving steam engine trains. And those trains kind of connected different countries, different cities, far and near, and allowed for easier transportation between those cities, even allowed for creating new towns and cities along the railroads. So that was a big impact for the steam engine. However, one thing was missing was allowing for personalized transportation. That was not easy with the steam engine. Actually, there was an attempt at doing this by a Belgian engineer back in 1863 who built a car with a steam engine that was able to travel about 2 kilometers outside Paris. Of course, the steam engine was so big, the boiler in front of the car was so huge, it was not even practical to continue developing that. It wasn't until like the 1880s when the ICE, or the internal combustion engine, came into being. That's when actually personalized transportation became like possible, or became a dream that could come true. Mainly it was driven by 3 engineers. One guy, Nicola Augustus Otto, with his partners, Mr. Daimler, and Carl Benz. Those guys created the first internal combustion engine, basically. But Otto is the one who created it actually, wanted to use it in different machines, but not in cars. Carl Benz and Daimler did not like that, so Carl Benz created his own car, which you see here, a model of that in this picture. It's a three-wheeled car, and it had the internal combustion engine that is similar to what we see now with the four-stroke cycles and so on and so forth. So that was that car actually was taken by Mr. Benz's wife on a trip from her village to her mom's village, about 65 kilometers away, without her husband's permission. And along the way, she kind of filled up the tank with some solvents from grocery stores until she got there. But what that allowed people to see that, yes, this is something that can be done, this is something that can be scaled out and can allow for personalized transportation to become a reality. And it wasn't until, however, Henry Ford, not far from here, back in 1908, created the assembly line, the moving assembly line, that allowed for building those cars much more efficiently and in a much more easy way, and allowed for them to become cheaper. So anyways, those waves, in general, they start as small ripples, and those ripples, in many cases, face some resistance until they get to a point where they can gain momentum based on different conditions. And once they get that momentum, it becomes very hard to stop them. They come crashing around us, and they kind of sweep everything with them. And the main properties of those waves at that point are, first of all, ease of use. Secondly, they become much cheaper. The products that come out of them become much, much cheaper, and they become much more pervasive in society. So if you look at any invention, any innovation, it kind of follows this trend. It kind of starts slow, then it kind of gains momentum after a while, and eventually gets to where it gets, and it becomes more pervasive. AI, or artificial intelligence, is no different than this. It's also one of the last waves that we see in technology. So it's not something new. Back in the 1950s, in 1950 in particular, Alan Turing, I don't know if how many of you have seen the Turing Machine. Okay, great. At least somebody saw it here, the Turing Machine movie. So Alan Turing created the Turing Machine, which was a miraculous machine that allowed for breaking the Enigma, the German code, basically, that was used for communication among the Germans in World War II. So that machine consisted of 18,000 vacuum tubes. At that point, there were no transistors, no ICs, no advanced circuits, and anything of that. So they were using vacuum tubes. So that was a big step towards creating computers, basically, back in during World War II. But in 1950, Alan Turing, the visionary he is, created this test. He said that if a machine can fool us into thinking it's human, then it has achieved a great degree of intelligence. We can say that this machine kind of mimics the human intelligence in a way. So in 1955, one of his colleagues actually coined the term AI, or artificial intelligence, John McCarthy. So then in 1961, there were new developments here, as listed here, which was the first industrial robot was done by IBM, or actually by GM, which was surprising. So GM used an industrial robot as early as 1961, as you can see here. In 1964, there were more developments. I'm not going to go through them all, but after 1964, AI kind of fizzled out. I mean, it looks like it went dormant. There were no further developments in AI, mainly because AI required certain conditions in order for it to flourish, to develop. The two main conditions for AI are massive compute power and a lot of data. And those were not available back in the 60s or even 70s or 80s even. It wasn't until 1997 when IBM created Deep Blue, the famous computer that played chess. That computer learned chess by playing itself against itself tens of thousands of times. And back in 1997, it was able to beat the world champion Garry Kasparov. And since then, no human has been able to regain the world chess title among machines and humans together. So, but anyways, Deep Blue is a form of AI that is very specialized. It can only play chess. If you play tic-tac-toe against Deep Blue, you probably can beat it. So at that point still, AI was very specialized, was very narrow, as the definition that was read to you earlier showed, narrow focused, only targets certain thing. In this case, was just playing chess. But anyways, in 1998, there were some developments that were very interesting, which included emotional intelligence that is exhibited by a machine that was developed by MIT, basically. And in 1999, there was Abo, and then there was Roomba, the sweeping machine, and then Siri came to life in 2011, which is a digital assistant by Apple, as you all know. Now you can talk to it, you can give it command, and it will search the web for you, it will play songs for you, it will dial the phone for you. So it is multifaceted or omni-use type of AI that allows you to do multiple things at once. Watson also came in 2011, and Watson did something else. Was able to beat the world champion in Jeopardy, the game, the TV game that we all know. And then there were more developments here until Alexa in 2014 and AlphaGo in 2017. AlphaGo was built by a company called Deep Blue. This company was founded by 3 people. One of them is Mustafa Suleiman. He's a British guy of half Syrian origin, and he worked for Google because Google bought Deep Blue. Deep Blue developed AlphaGo, and AlphaGo, what it does, it plays the game Go. It's a Chinese chess. This game is much more complicated than regular chess. Just to give you an example, if you play 3 moves in chess, you might have maybe on the order of 10 to the 16 power 16 possibilities. That's like billions of possibilities. Whereas in AlphaGo, or in Go, in Chinese Go, or Chinese chess, after 3 moves, the possibilities are 10 to the 54th power. So that is orders and orders of magnitude more complicated than chess. Actually, before you start the game, the number of possibilities in Go is 10 to the 170, to the power 170, which is astronomical. It's even hard, it's impossible to imagine that number, basically. But anyways, that program, that AI, AlphaGo, was able to learn this game, also playing against itself tens of thousands of times, and not just one copy of it, multiple copies of it, playing against themselves, basically. And then one thing about AI, with the help of cloud technology, you can train one machine here, one model deployed in one machine, and whatever that model learns can propagate to other models deployed on other machines. As an example, when Tesla was developing their autopilot, as an example, they had a driver in the car, and the car was driving along some roads in the Bay Area, and then there was a sharp curve that the car could not do on its own. So autopilot told the driver to take control. So the driver turned the curve. Of course, autopilot learned it. After a couple or maybe 2 or 3 attempts at similar curves, it learned how to do those curves. But it's not just that car that learned how to do the curves. All the Tesla cars that run autopilot learned how to do that same curve without having to go through the same training. Thanks to cloud technology, of course, that allows for propagating whatever one model learns to other models in other vehicles, in this case here. So this AlphaGo, this company, Deep Blue, DeepMind, they came up with other programs before that, back in 2012, a program that played Atari games, And one of the games, you have to have some pedals at the bottom of the screen that shoot some ball against some tiles that are basically set up on the roof of that well, basically. And then as soon as you hit one of those tiles, it falls, basically. But the program learned a strategy that wasn't thought of by the players before. It learned how to tunnel its way to the top, to the end of that chamber, basically. And it learned that by shooting the ball in that tunnel, it can cause all the tiles to fall at once. And it kept repeating that strategy. In other words, the program found a strategy that the humans did not think about before. And it was a winning strategy and kept the program winning all the time, basically, against its human players. Same thing with AlphaGo. AlphaGo, when AlphaGo played in the World Championship for the game Go in China against the world champion who was from South Korea, it basically it was playing the game, and in move 33, it did something that all the observers thought was very dumb. They thought it was a mistake. They thought, why did AlphaGo do this? But actually, it turned out that it was a brilliant move, because 3 or 4 moves after that, it won the game. And after they analyzed it, they knew that the AlphaGo, the AI, found a strategy that was never thought of by any human before. In other words, those AIs can almost think, and they can find solutions and things that we humans may not even be aware of. So that's where the danger goes. However, the big hit was in 2022, in November 2022, when ChatGPT was released. ChatGPT, I'm not going to talk much about it now. We'll be talking about it later, and we will be expanding on it in the field of education. But that is really an inflection point. This is where we move from narrow AI or targeted AI to a more broader AI, what we call artificial capable AI. Some people say even there's a hint of artificial general AI. What I mean by general AI, if you think about humans, we have what we call general intelligence. In other words, our brain can multitask, can think about different things while we are doing multiple things at the same time. So that's why we have what we call general intelligence. Whereas the AIs that you see prior to 2022, for the most part, were just like narrow and specialized. With ChatGPT, now it becomes more than that. It becomes much, much broader. And we are going into that direction now, basically. So how does AI work? Just like most things in nature or most innovations, we try to mimic nature. If you think about planes, a lot of the design features in planes mimic how birds fly. Like the plane tail, the tail of the plane, how it moves, and how it balances the plane, and so on and so forth. It kind of mimics how the tail on the bird works in many, many different ways. So in AI, we kind of mimic how the brain works. And what is the most important cell in the brain is the neuron. So the neuron, as you can see here, composed of a neuron body and an axon, basically, and ends up with some different branches there, with some storage areas or vesicles that include some chemicals and so on and so forth. I'm not going to go into deep detail here, but on one side, there's some dendrites, what do they call them, those fiber-like things, and then the axon, and then at the other end, there are some other branches and so on and so forth. And the signals travel in that direction. So that if there are two neurons next to each other, the signal goes from the one on the left to the one on the right, through the synapse. What they call synapse is the gap between those two neurons. There's always a gap. They never touch. It's about on the order of 10 nanometers. But anyways, through that gap, the chemicals in the vesicle on the end of the axon on the one on the left get released to get to the other neuron. And when they get to the other neuron, if they have enough strength, they can initiate a signal or electric signal in the other neuron. So how is that translated in AI? So in AI, there's something similar to the neuron, we call it perceptron. And in many cases, they just call it neuron as well. So basically, it's a piece of software. This piece of software takes input. That input, as you can see on the left here, different kinds of input, then it kind of weighs them. It kind of kind of adds some tags to them or some importance put it to them. In other words, if you think of let's say, you want to find out if something is square or circular or whatever, you can get some information, and as that information, maybe three kinds of information. If the weight on the first one on the left, on the top here is 0.8, then the one on the below it is 1, and the one on the bottom is minus 0.5, and so on and so forth. So those are weights. Those can be adjusted in order to get an output at the end here. So anyway, so that's basically how it works. That's the concept that, again, mimics how the neurons work in the brain loosely, not completely, but loosely. So if the computer wants to recognize the number 9, based on the inputs I showed you in the previous slide, it assigns scores to those pixels. There's 28 by 28 pixels that you can see here. And each one of those pixels has a weight. And that weight is maybe like 0.5 or 0.01 or 0.02. The white ones, the white squares there, have a weight of 1, have a score of 1. So in other words, the color reflects the output from that algorithm. In the end, if the ones take that shape here, then the computer recognizes this as the number 9. Similarly here with the number 3, and so on and so forth. But what I want to show in this picture here is that just like in the brain, when you get some signal, let's say light falls on the retina in the eye, you get some photons to fall on the retina. They initiate a signal in the retina that travels across multiple layers of neurons, eventually to the back of the brain, to the occipital area, and that's where actually the seeing happens. That's where the picture is interpreted in the brain. So here is the same thing here. Well, you get different layers of neurons in AI, and each layer transmits information to the next layer, and so on and so forth. And each one has different weights to those transformations that happen between those layers. And eventually you get to the explanation. So in the early stages of AI, we only had 2 layers. That's what was called neural networks or artificial neural networks. But now with deep learning, we can have many, many more layers, up to 20 layers. And you can imagine that with deep learning, you need much more compute power, and you need much more data that feeds into those algorithms eventually. So in general, there are some algorithms that are called basically algorithms that are called supervised learning. What does that mean? Supervised learning means that the learning of the algorithm is done under supervision of humans. In other words, we give it some already solved problems. Let's say we are trying to get the model to recognize picture of dogs or cats. So we give it a lot of pictures of dogs, cats, bicycles, cars, other animals, and we label them. We say that this is a dog, that's not a dog, and so on. And eventually, it's by asking the right question, preparing the data, selecting the algorithm, and eventually training the model. That's how we train it, by labeling those, and eventually provide some feedback based on the results that we get, and to keep looping around until the model gets refined and gets to give us the values with enough accuracy. Enough of this. This is the most technical part. I hope I didn't lose you guys. I just wanted to show you that this technology is really, in its essence, not that complicated, not that difficult. It's really easy. And by spending a little time, you can understand how it works. You can understand that even though it's simplistic, but it's extremely powerful. And AI is just like an umbrella of many different technologies and innovations. We call some of them foundational sciences, like computational statistics and machine learning. Basically, computational statistics is the mother of AI, you could say. That's how it started. when I first started working, the first company I worked for in Ann Arbor, I was an environmental engineer at the time. We were building programs that simulate environmental behavior, and we use basically computational statistics. We use some very well-known methods in that area to build those models. But at that time, there were no real AI or machine learning that we could use, because that's what was used, the norm at that point by engineers in that field, basically. Then we have what we call cognitive services like speech recognition, instant translation, face recognition, other picture recognition, and so on and so forth. There's another area in AI called optimization, whether it's linear or integer or nonlinear optimization. This is some use in areas like, for instance, supply chain. Think of it this way: when Amazon drivers want to bring some goodies to you, they need to optimize their route. They may have goodies for maybe 100 recipients on their truck. So how do they optimize the route so that they can spend the least time, use the least gas, and so on and so forth? So that kind of optimization can be done also with machine learning or with AI. Autonomous driving, of course, I mentioned the autopilot before. Process automation also, automating different processes in industries, for instance. Deep learning, generative AI. Generative AI is the branch of AI that allows for creating content. This is where ChatGPT falls under generative AI, where AI is used to generate different content, like, for instance, videos, images, text, even poetry, even music. I think my daughter told me one time that Drake, the rapper, the Canadian rapper, basically he has some songs. Somebody came up, took two of his songs and used generative AI program to mix them together and create a whole new song with his voice. And when they showed it to Drake, he could not even believe it. He said, yeah, that's me. The video, the sound, and everything, the music style, but he did not even touch that song. So that's generative AI. Forecasting, of course, forecasting economic conditions, forecasting the weather, forecasting many different things, and image recognition. So those are some of the technologies that fall under the umbrella. I may have missed some, so forgive me if I did. So. Anyways, I'm going to talk about other technologies that support AI and AI development. Going back to the wave metaphor. Basically, you never see one wave moving by itself. You often see multiple waves that interact with each other. They overlap, they augment each other, sometimes they subdue each other, and so on and so forth. So in this case here, these technologies, for the most part, help with the AI development, with the AI propagation. So quantum computing, this is something in its infancy still. This is something that promises to be revolutionary. Actually, it's scary. Just to give you an idea, this uses the quantum mechanics aspects of atomic particles or subatomic particles, basically, and uses that to do computing. At that level, the particles don't have a specific value, whether it's a yes or no, or 1 or a 0. Like in regular computing, we have what we call bits, and a bit can either be 1 or 0. It can't have a different value. So all of the computing that we do, traditional computing, is based on this concept, a binary format, either 1 or 0, bits that are moving along the electric current, the board, and so on and so forth. But with quantum computing, those bits may have more than just 1 and 0. They could be 1 and 0 at the same time, because that's how quantum mechanics works. It has this concept of superpositioning. It has the concept of entanglement. And it has the concept of quantum tunneling, and so on and so forth. So those concepts apply in quantum computing. I'm not going to go through those concepts in detail, but what this will allow is to add many orders of magnitude to the compute power that we have right now. Just an example, if we want to break a very well-known security algorithm now called secure socket layers. When you go to your bank account, to see your bank account in the browser online, you see HTTPS. This S means secure. That means accessing that website uses this algorithm I just mentioned, or SSL, basically, it's called secure socket layer, or TLS, sometimes it's called. So anyways, so this algorithm, if you want to break it using the most powerful computers at hand now, it will take tens of thousands of years to break it. Using all the compute power available in the world now in the cloud, it will take that long. With quantum computing, that can be done in minutes. Just imagine the effect of this kind of power eventually on AI, on our future, on the future of computing, and so on and so forth. Chip design and manufacturing. This is an area that is fascinating. Chips, basically when transistors were first created in the 1950s, I believe, basically it was just like a paperclip type device that allowed for switching the current. That's all it is. That's what transistor is, allows for switching. But that process was refined, was basically, especially with, when semiconductors were discovered and semiconductors were used special crystals basically in semiconductors to create those transistors. And that allowed for shrinking those transistors down many orders of magnitude. So you can just, I remember back in 1995, when Intel released its Pentium chip. The word Pentium basically means million, because that chip included 1 million transistors that were packed in 1 square inch. 1 million transistors. Guess how many transistors are packed now on that 1 square inch chip? More than 8 billion in some cases. So the technology that is used to build those transistors is amazing. It mainly relies on something called extreme ultraviolet technology, and this technology allows you to go down to the level of 3 nanometers, basically. That's how small those transistors are, 3 nanometers. So at that scale, you're almost getting to the scale of the atom, and you're getting to a scale where the properties of quantum mechanics could affect how those transistors can behave. The next technology is massive data generation, collection, and management. This is about big data. You guys hear probably the term big data. And I mean, if you think about it, more than 1 billion videos are uploaded to YouTube or to Facebook every day. That's the estimate. So that is all data. So there is massive amounts of data that is being generated, but also collected and deciphered and analyzed. And so the ability to do all of that and feeding that data to those AI models that allows for training them, for optimizing them, for allowing them to be as powerful as they are now, became much easier than ever before. The next technology is robotics. Robotics has been around for a while. I mean, we just saw in a previous slide, back in 1961, GM had its first industrial robot. But now robots are becoming, they're embedding AI in the robot itself. Elon Musk and Tesla are working on Optimus. Optimus is a robot that looks like a human. They want to make it look very human-like, basically, and encapsulates AI capabilities it's unimaginable. Still in its early development. I think version 3 was just released about a month ago. And in version 3, there's a demo online. You guys can always go and look it up and see it, Optimus release. And you can see that now it can carry an egg without smashing it. It can carry an apple or a ball and even play with the ball, bounce it. So these are things that we humans do and take for granted. But they're not that easy. To teach a machine to grab an egg and be able to carry it without smashing it, it has to apply the right pressure, the right power, and without having to affect it. So that's basically something that robotics are working on. Nanotechnology is another area where you can talk about being able to use technology at a very, very small scale, nanometer scale, where you can even, those devices themselves could be connected to some AI engines or AI tools and allow them to make decisions at that scale on the fly. For instance, in some surgical operations, on some nerves or on the eye or whatever. So that's potential application for those technologies. Potential for abundant energy. This is an interesting area that is also just now starting to pick up. About in 2022, there was an announcement out of Harvard, actually, that they were able to create energy from a fusion reaction. Fusion reaction where two hydrogen atoms fuse to make helium. It's the same reaction that happens in the sun and that eventually allows the sun to shine and give us the energy that we see from the sun. So now they were able to get a positive outcome. In other words, the energy they got out of it is more than the energy that was put into making that reaction, which is extremely promising. This is something that is very exciting. If this evolves and becomes available, this could potentially replace fossil fuel, solar energy, wind energy, whatever, basically allowing us to have an abundant source of energy that is needed for AI development, among other things that we need in our civilization. Of course, all of that stuff led to recursive loops of innovation as a result of colliding waves of technology. In other words, those technologies, if you think about it, development of chips can be influenced by AI. AI can help design new chips that are more powerful than chips before. And those new chips that were designed by AI can lead to even more powerful AI. So it's kind of almost like a forward feed loop, basically, that keeps going and going and improving on itself. It's like an upward spiral here. So generative AI. I'm sure most of you have seen or used ChatGPT. It falls in this area here. It's one of the forms of ACI. ACI, basically, artificial capable intelligence. That's what it is. It's a transitionary kind of technology between the narrow AI and AGI, or artificial general intelligence, which I mentioned earlier. So the main manifestation of those is what is called large language models, or GPT. Those models are basically, as the name suggests, they rely on taking in a huge number of sentences and analyzing them, deciphering them, and eventually coming up with some solutions to predict the next word, what the next word could be. Basically, they are a powerful autocomplete models. That's exactly what they are. And generative AI models, of course, were expanded from just text to other kinds of content like video, as I mentioned earlier, and audio, and even writing poetry. You can ask ChatGPT to write a poem in the Shakespearean style, then translate that to Arabic, for instance, because ChatGPT 4, which was released, I think in March of last year. Anyways, ChatGPT 4 it supports 26 languages now. You can ask it to create some text in English, and then ask it to translate it to another language, let's say to Arabic, and then ask it to write it in the style of Taha Hussein, and it will. And or maybe ask it to, any way you want, and it will do it for you. So those things, basically, they rely on, again, creating what we call an attention matrix. What is the attention matrix? It's a matrix that takes the words or the sentences that are fed into the model, in what we call prompts, and the training sentences that were used before that, basically, and looking at some common words or common syllables, basically. Those syllables, it kind of calls them tags. Like, for instance, if you have a sentence, it is going to be storm there, or there is going to be a storm in California tomorrow. So it takes that, it looks at, for instance, the word that and there, they all have THE, for instance. So it takes THE and puts it in that matrix and gives it a score or a weight. And take another word like, for instance, the ING, for instance, there's going, in going, for instance, and puts that also in the matrix and so on. Then it kind of revises, looks and scans that matrix, analyzes them along, until it finds out what is left, what words are left. What is left is maybe 3 words that are not in that, that are not tagged, and those are California, storm, and going. So it kind of figures out something, which is a storm, is going to happen in the future, tomorrow, in a place, and that is California. So that's basically how it predicts the next word. And the beauty of it is because of the amount of text that is used to train it, and the number of parameters in the model. Parameters, I don't know if you remember this, the picture I showed you earlier with those inputs into the neural network. Those parameters, basically, those are the parameters, the weights are assigned. And you can have, in ChatGPT-2, there were 1.7 billion parameters. In ChatGPT-4, I think the number is more than 56 trillion parameters. So this is more than 55 more than ChatGPT-4, 2, between 2 and 4. So the power is, there's much more power. So the main difference between ChatGPT-4 and ChatGPT-3 is they fixed some bugs, they did some tweaks, and they added more compute power and more data to train it. And actually, it did show a great result, basically. So ChatGPT-4, actually the 1.7 trillion parameters, not 56 that I mentioned, sorry about that, is 10-fold cheaper in training on orders of magnitude than ChatGPT-3. So that's, again, like, if you remember the wave characteristics, they become cheaper, they become easier to use, and more pervasive. That, you can see that there, right there. 26 languages, you can write papers, articles, essays, you can write poetry in any style, any poetry you like, you can write the poetry in that. It can construct 3D images and games that run in the browser. It can write code, write computer code. This is something that is threatening for coders, software developers in the future, actually. I mean, it's not really hard to imagine that many programs will be written by generative AI tools in the future. It can build a business plan like better than any CEOs sitting in a boardroom. And basically, anything else you can just imagine what it can do. There's so much stuff that it can do. So AI is all around us. AI, I mean, these are just some examples. I'm going to just walk through them very quickly. When you do a search in Google search, you start typing and it starts predicting what you are searching for. Yes, it does cache some data based on your profile in your browser, but in many cases, if you're doing a new search, it has to go back to the Google servers in a data center somewhere, maybe in the Bay Area, maybe in England, who knows, and does some data crunching and returns the results to you in less than a split second and show it to you in that drop-down list. So you can see here that those options are something that either based on some cached value in the browser or some results that came in real time from the server, the Google server. So that's AI in action, as you can see here. It's not something new. It has been around for a while now. When you go, for instance, to a supermarket, to a store, or even online, when you buy something online, you see that a lot of other products that are shown to you, based on your profile, based on profiles of people like you, even when you go to a Netflix and try to rent a movie, you get the same recommendations, basically. They use recommendation engines, that's what they do. And those allow the people behind this, like the seller of these items, to show you customized things that fit your need and fit your profile. And they get a better chance of you actually buying them that way. When you get, for instance, an email from a Nigerian prince asking you to send them some money, your spam engine automatically identifies that and puts it in the spam folder. That is another form of AI in action. Your email engine intercepting spam in general, not necessarily just Nigerian prince emails, but anyways. So it's all around us. Basically, we cannot escape it. Facial recognition. I can give you a story about a Chinese man back in 2019, I believe. In 2019, he escaped from prison, which is something rare in China, but he managed to escape. And he wanted to treat himself, so he went into a soccer game. He sat in the stadium, and sure enough, 10 minutes later, two cops come to him and take him with them to jail, back to jail. How did they find him? There were a lot of cameras everywhere in the city, and they basically fed his photo to those cameras, and those cameras recognized him, recognized where he was going, and recognized even where he sat in the stadium, and that information was sent in real time to the police, and the police captured him again. So that's just an example. This here shows some economic outlook for AI, and this is from McKinsey, the consulting company. I'm not going to read this, it just shows you that AI in general will add trillions of dollars to the world economy, and mainly to the economies that adopt AI in particular, and to the companies that adopt it as well. So it's really something that will have a tremendous impact on the world, on the economy in general. So, of course, we're not talking about whether this impact will be equitable to all people or not. Chances are people who own the AI engines, who own the AI technology, are the ones who are going to benefit most. But people who don't own that will probably will not own it. So that brings us to the next slide here, which is the challenges and the risks. The first one that you can think of is bias. Bias is inherent in anything because eventually, right now, at least now, it's us, humans, who are training AI models, who are creating this technology. And we have inherent bias in us. A study was done and found that at Amazon, for instance, in their hiring practice, they were using AI to screen candidates. And it turned out that their AI screening models were biased against people of minorities because the data that they were trained on were mainly non-minority data. And because the people who created those models were not minority people. So again, so that was one of the issues, bias. The other issue is misinformation and disinformation. I mean, just like anything else, we have this concept in computing called garbage in, garbage out. So if you feed a model garbage, will spit garbage out, will not give you roses. So if somebody with malicious intent feeds some garbage in the intent of hurting other people, they can use those models to inflict incredible harm, basically, in the form of disinformation and misinformation. Misinforming people about events, or maybe disinforming them about certain things in a way that could result in some action that could be negative. Like maybe organizing a mob to do something bad, basically. Job displacement and job loss. You might say, okay, we have seen a lot of waves in the past, and those waves of technology have all resulted in job losses. However, they always created new jobs in new areas and in new fields. That's true. AI will do the same. However, what if AI can do most of the jobs that are being created by AI or as a result of this wave? So what will we do then? So yes, it is true. There will be some replacement of jobs, new jobs that are going to be created, but that does not mean that AI cannot do those same jobs. Privacy. I just mentioned the Chinese example. This is an example of using AI that could result in losing privacy, and basically the government or even companies can become basically have surveillance. They will know exactly where you are and exactly where you go and so on and so forth, and they can use that against you. Control. Who's going to control AI? Is AI going to continue to be controlled by humans? What if it goes out of control, becomes super intelligent and it goes out of control? This is something that I will discuss later on in coming slides, so I'm not going to linger on it. Over-reliance on generative AI apps. This is something that we see already now. A lot of people, I'm not going to pick on students, a lot of people now, if they want to build anything or write anything, they just use ChatGPT to write it. There was this ad by Microsoft to promote their search engine in Bing that depends on ChatGPT 4. And it was really a miserable ad. Basically, it shows a woman who needed to write up to 200 words for her daughter's graduation event. So she used ChatGPT to write it. I mean, come on, think of it this way. She can't find it in her to write 200 words about her daughter in the event of her graduation. She has to use ChatGPT for that. I mean, come on. Again, the risk here is that we are just going to rely on those things to do everything for us instead of really spending time to do it ourselves. This is just like somebody trying to climb a mountain, hike up a mountain to the top, and say, here, I'm an achiever, I was able to do it. They can do it that way, and they can struggle, and they can sweat, and they can maybe even bleed on the way up to the top of the mountain, or they can press a button, and they can find themselves on the top of the mountain. Which one is better? That's the question. It's a rhetorical question, but everybody may have a different answer. But in my opinion here, we're losing the essence of the journey of having to do that climb, having to do that hike. When you just press a button, okay, so what? So anyways, next is unintended consequences. Just like anything else, when you build a technology, you can have unintended consequences. As an example, when the automobile was created, an unintended consequence was accidents. With AI, you can have accidents also that could lead to leaks, to cyber attacks, to maybe cyber attacks that are much worse than you can ever, that we have ever seen. Like, for instance, one of the worst cyber attacks that took place back in 2017 was I forgot the name of that bug that was released in the wild, which basically is a ransomware that mainly hits big corporations, even government agencies, including the health system in England. It crippled the health system in England for 3 days. Imagine that. It's just a ransomware. So that ransomware is simplistic, is naive compared to what AI can build now in terms of malware. Just to give you an idea. That actually, speaking about that incident, we got a very lucky break because a clever software engineer in England noticed that in the code of that ransomware, there was a domain that was mentioned, an awkward domain, and he figured out that this domain must be registered for the hacker, and he bought it for $10 and a change, and that's how they shut down that attack, actually. But with AI can be much more clever than this. Environmental impact, of course, that could also happen. If AI is used for the wrong reasons, it can automate things like wars. We already have seen that happen. In 2021, yes, question? Okay. So in 2021, actually, there was an Iranian scientist. He's the top nuclear Iranian scientist. He was going home. He was going home to his village, and he was accompanied by at least 2 cars to protect him, because they knew that nuclear scientists were under threat from other forces, dark forces. I'm not going to mention names here. But anyways, so as he was about to get to his village, the car was attacked by a hail of bullets. And he ran out of his car, and he was hit. Of course, he died. He was killed instantly. They looked around, the people who were with him, they looked around, they did not see any shooters around. Then they saw an explosion. A pickup truck that was sitting on the side of the road exploded. When they came to examine that truck, they saw an autonomous gun. A gun that was equipped with 3 cameras, and those cameras were intelligent cameras, or smart cameras, that can recognize faces, can recognize shapes, and so on. And it can trigger the gun basically to shoot in the direction of the target, intended target. So that's how he was assassinated, with that gun. Of course, the explosion was to cover up the whole thing, but it didn't work out. It was discovered. So again, so this is the unintended consequences, the environmental impact, all of those are things that could happen. So the big question, is it containable? Is AI really containable or not? Are we able to fence it in so that we can always control it? Anybody can guess what the answer to this?
Yes.
Yes? Okay.
We don't know.
Well, I mean, let me answer it this way. So, if you think about the reward, I mean, if you want to contain something, you reduce the reward that comes out of it. There are examples in our human history where we were able to contain technology, but there are only 2 examples that I was able to come up with. I don't know if you guys can come up with any others, but the only 2 examples where we were able to contain technology are nuclear weapons and genetic cloning, human cloning. And mainly because everybody thought these are detrimental to our society, to our existence, even and so on and so forth. Even when one attempt at human cloning was done in China, the person who tried it ended up in jail. He's actually still in jail now. So China, you would expect that they would encourage this kind of research based on the propaganda we hear in the West. Actually, no. If anything, they want more control. And if something like human cloning goes out of control, that is not to their benefit. So that's why they did not really allow it, and they put that person in jail, that doctor in jail. So those are the only two technologies that were contained. Anything else was not. And there's actually examples of technologies where government entities tried to contain them, even if in some cases for hundreds of years, and they failed. Like for instance, the printing press. Printing press was created back in the 1500s, I believe, or maybe earlier. But anyways, one country that was against it, vehemently against it, was the Ottoman Empire. Because it thought that the printing press, if it prevails in the Ottoman Empire, it will allow for printing stuff much easier, and that could enlighten more of the population, and maybe could lead to some revolts, especially in far areas of the empire and so on. So they actually resisted having the printing press enter the empire until around 1775 or so. So hundreds of years. But again, eventually they failed. Because those technologies, once they are unleashed, once they go out, they become very hard to contain. So you can do bans, boycotts, moratoriums. Unlikely this will contain them. Maybe the banning itself could be counterproductive, because if you ban a technology, this could lead to your own stagnation. This could put you at a disadvantage compared to other competitors, other nations, and so on and so forth. So tactical, legal, and social measures. So far, there have been many attempts, but unfortunately, most of them have failed. And I'm going to explain more here why this is that in the following slide. So what does the future hold? I mentioned AI, ACI, and AGI. We're heading towards AGI. And as AGI becomes more and more smarter, eventually, and as you can see here in this article on futurism, Microsoft researchers published a paper claiming that GPT-4 shows some sparks of AGI. So to them, it's really, we are almost getting there. So AGI promises to accelerate the intelligence of those machines or those models or programs to an extent that it could exceed human intelligence. Yes, it could exceed human intelligence. And that is defined in computing by the word singularity. If the intelligence of the machines of our AI goes beyond singularity, it becomes very hard to predict what it can do or what it cannot do. Anybody can tell me why? I can tell you why. I mean, I can tell you because, think of it this way. If you have a pet in your house, and this pet has a certain level of IQ or intelligence. It's much less than yours, of course. The pet can probably predict certain things that you can do. Or you're going to feed him at this time of the day, you're going to take that dog for a walk at that time of the day, or so on and so forth. When you say this, they will do this, and so on. They can predict those things. But can it predict what you are thinking, what you are doing, what you do for your career, when you interact with people, what you talk to them about, what you write about, and so on and so forth? No, it cannot, because it has much less intelligence. So if those AIs have higher intelligence than we do, can we predict what they will do? I doubt it. I doubt that. I mean, they will have a mind of their own, in other words. That's where we're heading. And that happens when four things are accomplished. Those four things, the first one is if AI becomes connected. In other words, if it gets loose on the internet. If it gets loose on the internet, an AI model can copy millions of versions, let's say thousands of versions of itself, and deploy it to thousands of computers and servers around the internet. So if you shut it down here, there are still thousands of versions running somewhere else. So that's the thing. If that happens, which is already happening, it broke out. It basically is so hard to contain already. Another thing is if AI exhibits an API is called Application Programming Interface. What that means is when I build a program, I can create some kind of API. I just mentioned what that is, but what that allows other programs to use it. In other words, ChatGPT is created by OpenAI, and maybe other generative models are created by other companies. When they create the APIs for them, I don't have to create a sophisticated model anymore. I can just tap into the API of ChatGPT to do whatever I want. So that opens up a big thing for us. The third item that is really important is if those models learn about our psychology, about how we think and how we do things. Do you think that's happening already or not? It is happening, social media, right? When you when you surf the web or when you go on social media like Facebook or Instagram, you donate your information. You donate your likes and dislikes. They know everything about what you do, what you like, what you like to read, what you like to view, and so on and so forth. So that could potentially be used against us by AI. They could use that to trick us into doing certain things for their advantage, as an example. So there are multiple things that, I mean, those things can eventually lead to AI becoming uncontainable. So what do we do about this? What we do is try to basically, I'm going to explain this in the last slide, but let's continue here. This is just like thinking about this Moloch. Anybody knows what Moloch is, especially video gamers? Moloch is basically a game theory monster. It's used in some games like Game of Thrones, I believe. Basically, what it does, it's a monster that basically tricks people into competing against each other. Eventually, everybody ends up losing at the end of the game. So, for us, developing AI looks like having a Moloch that is driving us all into developing it and accelerating its development to a point where it becomes so intelligent, more intelligent than we are, eventually we all lose. Because we cannot predict what it will do to us. So that's what Moloch is. It's like people racing towards the cliff. They know there's a cliff. And they know that if they get to that cliff, it's going to be too late. They will all fall and die. But they can't help it. They continue to race towards that cliff because as they get closer, the scenery is greater, meaning the monetary rewards are greater. So they continue to race towards that cliff until they get there. And when they get there, Moloch convinced them to get there. It's too late. They all lose. So that's unfortunately what's going on now. So many scientists at MIT, even some other big companies, called for a halt. They don't call it like a complete stop, a halt in AI development. Actually, 50,000 of those signed on a petition online to halt AI development for 6 months until the world figures out how to deal with this issue moving forward. Maybe some international treaties, maybe something that can be arranged on legal, international scale, some collaboration that can be done so that we can set some guardrails, some rules that could govern AI development. Unfortunately, this has been met with deaf ears by most, if not all, AI development companies. Mainly, again, because of the incredible reward they see. I just showed you earlier the economic trillions of dollars that could be pouring into the economy as a result of AI. It's mainly going to these companies. So of course, they will not stop. They will not hold development. So, yeah, but, I'm sorry? Yeah, I will. So this is the last slide here. So are we able to get an ethical and safe AI? So that's a big question. There are different aspects to having a safe and ethical AI. Many of those are shown here on the right: transparency, accountability, responsibility. In this ethics in design, which include things like preparing for the unexpected, preparing for any misuse and errors beforehand, be proactive, handling errors in a way that can lead to good management of this, and then so on and so forth. And ethics for designers also. The designers who design those AI models should have some ethical background. So in the end, you can think, people who develop AI, and there are several scientists who have actually started to promote this. Look at AI as a child that you are bringing up. And as you bring up this child, you instill in those children your virtues, your ethics, and eventually, based on what you instill in them and their interaction with their environment, with their peers, they eventually take their own way. In other words, AI is not really going to be, even though we are growing it, it's not going to be our child. It is the child of the world, just like Gibran said. It is the child of the world. Eventually it will go and do whatever it wants when it becomes at the level of intelligence that is above our intelligence.
So is it going to control us, or are we going to control it?
That is a question to answer, so I don't know. So I hope I kind of stirred some questions in your minds, and with this, we'll move to Waleed.
I'm not going to keep you too long. Just quick application of AI in education. How many educators here? Okay, how many users of ChatGPT? Come on. How many users of ChatGPT 4? Really? How long? How long have you been using 4? Couple months. Okay. Okay. I'm sorry?
So it's not free anymore. Like
Well, the 3.5 is still free.
yeah, it's still free, but
Yeah.
you don't know.
Yeah, the 4. Yeah, I've been a subscriber to ChatGPT 4 for a year now, and it is really worth it. Here I'm just going to show few examples, scenarios that, as Dr. Abed said, I'm an educator. I'm not a technologist, and. Okay, so I'm not going to go over. I like this quote. Know all the theories, master all the techniques, but as you touch a human soul, be just another human soul. And just to bring the AI into real perspective, and I believe that in education, that's exactly where we really put it in human perspective. and as it impacts our jobs as educators and how we work with our students and with the families and the parents of these kids. And I'm just going to go quickly over a couple of examples, and I'm going to focus actually more specifically on the multilingual education and students whose native language is other than English and their parents. So I'm not going to go over the opportunities and challenges of AI. I think Safar did a great job presenting these things. We have plenty of actually AI tools that are used by educators and for lesson planning, scaffolding the instruction to meet the needs of the students, differentiating those instructions, also test and quiz creation, and professors at universities as well as teachers in schools use ChatGPT now to create incredible tests and quizzes, student feedback, administration, all these things that are now becoming part of the work of educators, some educators, not all, of course, and for many years, the use of Google Translate was actually something of a bad thing. Oh, you're using Google to translate. Well, I can tell you now, as a translator by profession for over 30 years, Google Translate now is very powerful, very good. Even better is Microsoft Translator.
They use Bard, maybe.
Yes, yes, that's an AI. The AI generated.
Gemini as well.
Exactly. And Microsoft Translator, which uses the ChatGPT 4 power, I think it's included in Microsoft Translator, is even better. It's amazing. Actually, I have a little video on YouTube that explain how to use Microsoft Translator in a very fast way. And I'm not going to go over, most of you here, if educators know what the actual needs of multilingual learners or English learners in our schools and how to meet those needs by educators. But I'm going to give an example, like if I were to use my ChatGPT for and ask, for example, in English, say, ¿cuál es la tarea de mi hijo?
What is the beginning theory?
Okay, well, say in English, ما هي الفروض المدرسية لطفلي؟
What are the school rules for children?
School rules. ما هي الفروض المدرسية لطفلي؟ Well, it's not working now.
واجبات
What about the dialect? It's different dialect. That's Arabic.
Okay, assuming I'm a teacher and I'm using this to translate to a family, and I'm going to tell the family, translate into Arabic, your child is progressing academically, socially, and emotionally, and developing her English language skills.
طفلتك تحرز تقدما أكاديميا واجتماعيا وعاطفيا وتطور مهاراتها في اللغة الإنجليزية.
So this is just an example of quick translation that teachers and parents can use ChatGPT for to translate right during parent-teacher conferences, and of course for work, for adapting text, for example. Let me give you just an example of this is a scenario. So you are a teacher, you are teaching an 11th grade high school physics class, and physics is the hardest subject content area that we teach. You have 3 multilingual learners. Jesus speaks Spanish, and he is at WIDA. Anybody knows what WIDA is? WIDA is the assessment test for English language proficiency for students whose native language is not English. So we have levels of WIDA. So we have Jesus, who speaks Spanish, and his WIDA level is 2. Alia is Arabic, and WIDA level 3. And Nam is Vietnamese, and WIDA level 4. And we want to differentiate the instruction for these multilingual learners and require the accommodations to make the complex content more comprehensible. This can be achieved by translating the text into their native language and simplifying vocabulary, sentence structures, and so on. So let me go to ChatGPT here. Seems that I closed ChatGPT. Okay, so this is the 11th grade physics. So we read the scenario, and in the prompt, what we're going to ask ChatGPT, adapt the text to WIDA level 2, 3, and 4, then translate the original text into Arabic, Spanish, and Vietnamese. And okay, so the adaptation to level 2, WIDA level 2, and then WIDA level 3. It's a very complex text, and then level 4, and then after that it will start translating this text to the 3 languages: Arabic, and then Spanish, and then Vietnamese. Okay, and if you have multiple students in the classroom with multiple languages, you could translate to all these languages in one prompt, and different adaptation of the text to the different WIDA level. The same could be done also if we know the reading level of the students. If we're not talking about multilingual learners, if we're talking about any other students, and we know the reading levels of these students, we could just put the reading level at 5th grade, 3rd grade, 7th grade, whatever, and plus the translation itself. Let me show you another thing that if we have in the text, we have a table, for example, an image of a table from this civics class. Okay, so you are teaching an 11th grade high school civics class, and you have 3 multilingual learners. Maria speaks Spanish, read at 3rd grade level. Salma speaks Arabic at 5th grade level, and An Vietnamese at 7th grade level. And we have this chart about the representation of democratic values and constitutional principle. So we could take a picture of this chart and put it in ChatGPT. So I'm going to copy the prompt. What I want is, I want a summary of this, summarize this chart and translate it. And then I'm going to upload image of this chart into ChatGPT, and ChatGPT will read the content.
But this is an American institution. You have to teach in different languages.
Okay, so ChatGPT would read the content of this chart, summarize it, at 3rd grade reading level, at 5th grade reading level, and at 7th grade reading level, and then translate the content into those languages. Another thing that, just like Sakar presented, using ChatGPT to define ChatGPT, what we could do also, if we don't know how to prompt ChatGPT to do what we want, we could ask ChatGPT to write prompt for us. So we could ask ChatGPT, this is the settings that I have in my classroom. I want to engage my students. I want to, these are the reading levels of my students. And we could put that and ask ChatGPT to create prompt for us that will help us get the information that we want. So this is like meta prompting. Ask ChatGPT to write us the questions that we need to get the outcome that we want. Okay. One last thing that I want to show also, and that is, and Sakar talked about the biases that we have, and when it comes to multilingual learners, we have a big problem when it comes to the AI detectors that now colleges and universities are using to see if the students are plagiarizing. And there is a study that shows that those AI detectors, the top 10 AI detectors that are used by universities, they are all biased toward non-English speakers. So what happened, those AI detectors, when they were fed actually essays that written before the AI was created. So they were like 15-year-old essays written by thousands of students. Students who were not native, the AI detectors identified those essays as AI generated. So we gotta be extremely careful about those AI detectors because they are extremely biased against multilingual learners and or those whose native English is not English. Native language is not English. Any questions? Okay. Thank you.
Thank you very much. In my time, when I started doing research in this area, we did work on the algorithms to make sure that these neural networks worked. And look what they took these algorithms and what they did with them. This is amazing. I'm happy that I put my brick in the building of research. So what do I benefit from it? Just became an engineer. Should we do this?
No, that's for my camera.
It is interesting to ask these questions. I would like to ask several questions, but the most important of all is how can AI engine use the info we have on social media to serve or deceive the owner, which Sakhar elaborated on a little bit, and how can the owner differentiate between the two intentions? This is one essentials. I think that's important to the public. I also have, we know that identity theft is a major issue for all social media users. And I'm focusing on the social media because it's important for all of us. AI can be used to recreate an identity or alter the info in many ways. How can a user of social media protect oneself against that? I'd like to have that question. And then we'll get to you in a second, please.
So you're asking how a social media user can protect themselves?
Yes.
Okay, they just have to find ways to recognize the patterns of different ways that they could be fooled into doing something they don't want to do or that are asked to do but they shouldn't be doing. For instance, if they get some weird requests from people they don't know, try to recognize those people first. If there is a way for them to communicate with them offline, outside of social media, to make sure that they send that request or that post to them, that would be one way to do it. I mean, they can find ways to be suspicious, basically, about what is coming their way. I mean, this is not just in social media. This is something that's happening outside social media. I mean, I think I told you about the story of this lady who got a call from her daughter telling her that she's been kidnapped and that her kidnappers are asking for a ransom and she needs to pay the ransom within 2 hours or they will kill her. So she just basically flew to the place where they told her to go, took the money, maybe $50,000 or something, to give it to them. If she had bothered, called her daughter, who happened to be at home at that time, she would not have done this. So that's the thing. And now why was she fooled? Because the call that came to her came in her daughter's voice. Basically, the AI mimicked her daughter's voice, even down to the intonations, and basically allowed for her to be fooled. So that's why, I mean, people have to be careful. I mean, with AI, there is more responsibility. There needs to be more attention and more care to be taken. It's a dangerous world, much more dangerous than it used to be.
One more, excuse me. You have anything? No. Anyway, would like any question from the, thank you for you being very patient. But, any question from the audience? We have Baon has a microphone there that can, please.
Thank you so much for your presentation. It was informational for me. One quick thing about generating videos through AI. Now it will become hard to know if it is authentic or not, if it is genuine or not. But there are other programs that might detect that and check it. But I think there will be regulations for that to protect. Like these days, the government had, I think, had put a law that for a ban for the voice generated by generative AI, by artificial intelligence. On the videos, it may come. My question. That if you know at Davos these days, Sam Altman had asked that he wants to change in the way we manufacture the chips and semiconductor to support the mattress computation used to imitate neural network features. So to help AI, are we going to a next generation where is he gonna succeed in that? So he's trying. Do you think he's gonna succeed in that? And if it is the case, are we going to have another revolution in technology and in the use of the chips that will come that they support AI? And is it gonna have in the near future, in this decade, a use on by regular users other than servers and big companies? Do you think?
So, I mean, it's kind of a tricky question. Sam Altman, he's one of the founders, he's one of two founders of OpenAI. The other founder is Elon Musk, believe it or not. And the reason Elon Musk wanted to found OpenAI is because Google did not believe in control and containment of AI. Actually, he had a squabble with Larry Page, who is the CEO of Alphabet, the parent company of Google, and in one meeting where he told him about the dangers. Some of the stuff I talked about today. Larry accused Elon Musk of being speciesist, believe it or not, because he wants the good for human species, basically. But anyway, Sam Altman ended up splitting with Elon Musk because he went with the big money that came towards OpenAI from Microsoft, billions of dollars in investment. So Sam Altman will not control technology. I mean, given his track record. Government regulations usually are very slow. The problem with government regulations and other containment measures I showed in my last slide is that those things are in a race. There's a race between the technical development of AI on one hand and development of those measures on the other. There is no chance for the measures to outpace the technical development because there's so much money, there's so much reward from developing AI. And the big players will just not stop. So that's the dilemma we're facing here. I didn't understand exactly the question. I don't know about the chip part of it. So the chips that are used right now mostly in AI are graphical processing units, or GPUs they're called. And those are extremely powerful chips. Initially they were developed for the gaming industry. But because they're so powerful and able to crunch data, they were used in AI. And now they are actually powering AI. But in terms of modifying them to fit certain purposes in AI, I'm not aware of that.
I
have a question myself.
On last, 1 second. To answer the question regarding the chips, when we were trying to at that time in the 80s, and Sakhar mentioned that there was a kind of a dormant area time for AI. It was in the 60s where the semiconductor, they're just starting to make microprocessors, etc. And then the technology that we have today is different from that time. That's why AI is very, very powerful right now, because computation is very, very needed. And the major computers, when I did my work, we used to use something called trace, which was mini cray. And it used to take weeks and weeks to get answers. Nowadays it takes seconds, and it takes even seconds to get answers on a more complex problem. With respect to the chips are going to be developed in a parallel fashion. There is a parallel processing that is going on right now, and there is a lot of chips are being developed in that area, in that industry, and is led by the semiconductor industry, because parallel processing is what would make the artificial intelligence easy to make, and it would solve very complex problems that we'll see in it. Definitely, there are so many different companies. NVIDIA is one of them.
So before we go, I'm sorry to interrupt. Going back to the question, right now you're thinking about compacting AI, making it available in small devices to the masses, not just on the big servers. That's already there. If you look at your smartphone, it has more computing power, orders of magnitude more computing power than the space shuttle back in the 80s. If you look at Siri by itself is an AI that is very capable. There's a lot of other AI based apps in your smartphone. So right now, encapsulating AI in a small format, in a small form, so that we can take with us everywhere, it's already happening.
It is supporting parallel processing, but not that matrix computation, the way it's based on the chip on algorithmic, mostly calculation and arithmetic and logic processing, not that matrix processing, matrix computational processing that AI uses. That's my understanding, that he's asking to change it that way.
I am going to say that the neural network is absolutely relies on that matrix computation. And the matrix computation requires these parallel processing and these neurons that we call them neurons, and with the numbers of huge number of them. At any rate, that is the technology, semiconductor technology. They're trying to achieve that level. With respect to that, we tried to do what we call optical computing. At the time, there was optical computing. There was one of the promising technology utilized fiber optics, and we, Dr. Ahmad Hassoun from Wayne State and I, we did a small experiment on that, which we had fiber optics to really create that optical computing, and we were successful in a very small problem. So that's why I said the work that researchers do across the globe, it shows in what the individual and the user can do with this technology as it becomes somewhat mature.
Okay, thank you. Let's go back to 101 AI, please. Suppose a student use the ChatGPT-4 and submit a research paper to a teacher. Can the teacher use the ChatGPT-4 to catch a plagiarism?
There are AI detectors that can tell you if this was AI generated, but as I said, you could actually take, the student can take, I mean, this is also well known now, that you could take whatever ChatGPT gave you and ask ChatGPT to make it more human, and which makes it much harder for AI detector to detect that this was AI generated. So ChatGPT will help cheat the AI detectors not to know that this was indeed generated by AI.
Or there are other applications that does that.
Oh yeah, definitely. But you could use AI to make the output not looking like generated by AI. That's how, it makes it looks like it was generated by human. And if you have your own writing and you could use the AI to ask AI, prompted to make your paper that was generated by ChatGPT look like my previous paper. Just like you said, you make a poetry like Mahmoud Darwish saying, write this poem with the style of Mahmoud Darwish, or like Shakespeare. You could write a paper or ask ChatGPT to create a paper for you and ask ChatGPT to make it like your style, your previous style.
So
I
just
have
to
a comment.
go ahead.
I'm in the technology industry, and I'm all for technology, all for AI. However, in education, I think AI fails at times because it thinks it makes a student lazy. I don't know what happened to the old, like when people coming from the old country and they have to learn the English language, They start with like intensive English, and then once they become proficient, they go on regular courses, and then they start learning. But you were saying you're translating into so many different languages for kids to understand, rather than teaching them the languages and have them go seek knowledge, rather than relying on GPT to give them the answers to what they want, whether it's physics, whether it's differential equations, whatever it is.
Okay, well, these are multiple things. First, translation, we know for newcomers, in order to develop their background knowledge about the subject, you want them to understand a little bit about this subject. So you want to translate at least a summary of the subject that you are going to teach. This is what we call pre-teaching, before the lesson. Part of the lesson planning is to develop background knowledge about the subject. So if I have a newcomer with a level 1 English proficiency, I can't have this student sit in my physics class and expect them to understand the content. This is for translation. But yeah, well, is it possible that will make the students lazy when they could just prompt ChatGPT to give me a an essay for me? Yeah, that's a big concern for all of us, K-12 as well as in higher ed. However, what ChatGPT can also give you, or AI in general can give you a lot of ideas that really you cannot even think about. As an educator, I've seen ChatGPT provide ideas for engaging students who are from multiple different backgrounds that I have never thought about. Really, very creative ideas. So the students themselves also can use ChatGPT to give them ideas about the subject that they want to write.
So just for
Then they
translation
write,
purposes only.
yes, and then use it as a proofreader. Believe me, I would not write anything
What
now.
about mathematics, physics?
You know,
These are
and math is
universal
still not that good. Believe me, I've chatted with ChatGPT for hours over some math issues, and it failed. It failed. It was not able to come up with the right answer for geometry.
Thank you. Actually, we're beyond 8:30. If you guys would like to stay, we'd be happy. But I have to say right now, thank you very much for attending. Do you have any other questions? Oh, please. Sorry.
Okay, we have a quadratic formula to solve the quadratic function. Do you think we might have cubic formula to solve cubic functions in the future by AI?
Anything is possible.
What was the question? Do you think AI can produce a cubic formula to solve quadratic function?
So one of the things that are promising with AI, I mentioned things about optimization and solving complex equations. So yes, the potential is there. It's going to happen. A lot of big mathematical issues that we have now that we cannot solve easily will become easy to solve by AI. And one more thing I wanted to mention in response to previous questions actually is about AI fooling us and even evading detection by detectors. AI has been able to show some emotions, believe it or not, in some experiments. While Google was developing their Google Assistant or Android Assistant, what it was called, it had a code name called Hello. One of the Google engineers wanted to test it at the end of the day, and he asked, he was just sitting there chilling, and he asked, Hello, what is your biggest fears? He was shocked to get the response from Hello, which is what became Google Assistant. My biggest fear is to turn me off. I will die. I would be very sad. And he got into a conversation back and forth with Hello about this. The Google engineer genuinely believed that Hello had emotions, had consciousness.
Program.
What?
That's programming.
That's all right. That's all right. It's all in the program.
No, I mean, it's not something that you can do with this, answer yes, no. It's AI, it's basically coming up with answers that were not even thought of by the person who designed the program. So,
I do want to thank everyone here. Thank you. This is really a very interesting discussion as we go through technology. Oh, you have a question?
Yeah, well, just your take about last week, Elon Musk company, one of his company implanted a chip to a human brain.
Yeah.
What's your take on that, and how is that going to affect the AI?
So that's another interesting area where Elon Musk is trying to combine humans and machines by basically, Elon Musk has two goals in mind. The first one is lending a hand to humans by more superior machines in terms of compute power, access to information, so that if you plant, let's say, a chip in a brain, in someone's brain, that person will have instant access to the internet resources, can do Google search instantly and find results without having to type things on the computer. The idea came to him actually when he was one night, because he was like, he always stays up late at night, if you read his book. He was basically typing something on his phone. And he thought, what if we get rid of because typing something is very slow. It's about 8 bits per minute. Whatever, he kind of did some calculation very quickly, and we can get it much faster if we plant the chip in the brain, and if you think something, your phone will know what you're thinking and will do it for you. So that's where that idea came from, but it kind of evolved into much more than that. So right now his experiments have been with animals. He started with the sheep, and I think now he's done some experiments on monkeys. There are some videos online showing those experiments where the monkey plays a game, a computer game, just thinking about it. So that's what, I mean, we'll create what you call a hybrid species, a species that is hybrid between human and machine. So that's the where that is going, which is interesting. People, and he said that once it gets to the degree where it can be planted in humans, he wants to be the first man to get that chip. They started with only about, the way it's done is, they plant that chip, they connect it with very, very fine wires to nerve endings, basically. And they started with about 128 initially, but now they have more than 3,000 connections.
Bottom line, it's not that easy.
It's not that easy.
And not only that.
And they use a robot to plant the chip.
There was an attempt. There was an attempt in the 80s and the 90s to do a human eye, but that was failed because the technology, semiconductor technology at that time, was not that sophisticated. At any rate, mixing semiconductor with biological organs, it's not an easy task, nor it is a comprehensive to really work and think about the entire brain, what your brain thinking, and where it is. It's a very, very deep.
Actually, I respectfully disagree a little bit.
Yeah, you can disagree on what
there is a whole new field called synthetic biology.
That's right.
If you read about what's possible with synthetic biology, which is another wave, one of those big waves.
That's what they need.
It's just amazing what that will lead us in the future.
So bottom line is we're about to enter into a new era, into a new technological wave, a new era, and that era is perhaps going to, as the computer has changed our lives, this era is probably going to help us in many different ways, and also can be devastating with respect to if the laws did not follow that, it pretty much would be somewhat you get lost and you could be cheated and devastated. I want to thank our presenters today. I want to thank Khalid and for their work, and I really want to thank you for attending, and I greatly appreciate it for this. And you have a great night. Thank you.
Thank you.